Someone's asked me to go through exercise 16e question 8, which is the one where the acceleration is this for the first 5 seconds and it starts from rest. First question is explain why v is greater than 0 for those 5 seconds. Well, for that we have to look at this here. So when t is 0, v is 0, and a is an expression squared. It's t minus 5 all squared. A is always positive. A is greater than 0 because t minus 5 is greater than 0. T minus 5 squared is greater than 0. In fact, greater than or equal to 0, isn't it? Greater than or equal to 0 for that time period. So if the acceleration is always positive, it's always getting faster. It doesn't matter whether it's a big or small acceleration, it's always getting faster. And the smallest it was 0. So, and the time period was between 0 and 5, was what the question asked. Second question was, find the average speed for the first 5 seconds. To find the average speed, we need the distance travelled divided by 5. Now, we've currently got acceleration, so we need to find the velocity and then we need to find the displacement. One important thing to say is, because the velocity is always positive, because the object is always moving forwards, the final displacement will be the distance travelled. Okay? In this time period, the velocity is never 0. Okay? Because it's accelerating, the acceleration is positive all the time. All the time. There's never a point when the acceleration is negative. So we get that v is the integral of a dt, which in this case is going to be, I'm going to put the 10th outside, integrate t minus 5 squared dt, which is a 10th of t squared, take 10t plus 25 dt, which is a 10th of t cubed over 3, take 5t squared plus 25t plus c. T is 0, v equals 0. When t is 0, v is 0. So if I put a 0 here and 0's here, we find that c is 0. So v is a 10th of t cubed over 3, take 5t squared plus 25t. S is the integral of that. So again, I'm going to put the 10th in front. Which is a 10th of t to the 4 over 12, take 5t cubed over 3 plus 25 t squared over 2 plus k. It wants the distance travelled from where it started, so we can say when t is 0, s is 0, and if I put 0 here and 0's there, I get k is 0. So distance travelled in 5 seconds, we get s is a 10th of t cubed over 3, t to the 4 over 12, take 5t cubed over 3 plus 25t squared over 2, when t is 5, s is a 10th of 5 to the 4 divided. So that's 0.1 multiplying 5 to the 4 divided by 12, take 5 times 5 cubed, so that's going to be 5 to the 4 again, 5 to the 4 divided by 3 plus, oh, that's going to be 5 to the 4 again, 5 to the 4, that would have been a quicker way of doing that, wouldn't there? 5 to the 4 divided by 2, close brackets, equals 125 over 8. Actually, I've done that in already, about 125 over 8. Therefore, average speed is 125 over 8 divided by 5. 125 divided by 8 divided by 5 equals 25 over 8, 3.125. Part C is strange. By sketching the graph of V, show there's a value of t at which the instantaneous speed equals the average speed. So the graph of for the velocity, we know it starts at 0. We can work out the speed at 5 seconds. So let's work it out there. Oh, it's going to, with 5s, it's going to be nice and easy again, isn't it? So what could we do? Is there a quicker way of doing that? I'm sure there is, but I can't think of it. So 0.1 multiplied by 0.1 multiplied by, oh, they're all 5 cubed, aren't they? Right, so let's do 0.1 times 5 cubed multiply 5 cubed multiplied by a third, so 1 divided by 3, take 5, no, that's, sorry, I was making a meal of that. So all I've done is I've typed in the actual sum I should have done, and that gives 25 over 6. 25 over 6. So why have I done that? Because at 5 we know the velocity is 4.2, and the question is, show by sketching the graph of V, show there's a value of t at which the instantaneous speed equals the average speed. The average speed is 3.125. You can sketch it on your graphical calculators. You get that shaped graph. That's V, that's t. If the velocity goes from 0 to 4.2, it must go at some point, it must have a value which is equal to the 3.125. And that's actually what it's looking for that question. Sorry about making a meal of the working there.